Assalamualaikum and a very good day to all. For today, we are going to present our research upon natural methane hydrates extraction and production processes. First, allow me to introduce the member of the team. Myself, my name is Dayang Sharifah Roselia, Nurizati Hazwani, and Muhammad Afiq Salahuddin. Okay, what is gas hydrate? Gas hydrates are the mixture of methane gas, carbon dioxide, and hydrogen sulfate. It was first discovered in the year 1910 by Sir David Humphrey. The formation of gas hydrate depends on several conditions. Next is methane hydrate. Typically, methane hydrates are referred to as natural gas hydrate, which consists of gas and water. Meanwhile, the production of methane hydrates is done by dissociating the methane hydrates to methane gas and water. Methane hydrates initially exist in solid form in the layers. The production of methane hydrate means dissociating methane hydrates in the sheet and collecting the resultant methane gas through the production system. Problem statement. Due to the global population and economic growth, the world demand for energy is rising. Nearly 80% of the world energy supply is generated from oil, natural gas, and coal. The combustion of this fuel is the main source of carbon dioxide emission, leading to greenhouse effect. The potential solution to this problem is geological of natural gas hydrate. The aim of this study is to investigate the natural methane hydrate extraction and production processes. Corresponding, there are few objectives that are needed to be achieved in the study, which are to understand the process and operation of natural methane hydrate extraction, to identify the advantages, disadvantages, and challenges of natural methane hydrate extraction, as well as to analyze optimization approach available towards the extraction process of natural methane hydrates. Methodology. The project started from problem statement finding, gaining an input with various sources of literature review, discussion based on literature review obtained, and making relevant conclusion in accordance to the finding. Moving on to the discussion, which are mainly made from literature review, is the natural methane hydrate extraction process and operation. Equation 1, which is the formation process, is an isothermic process, whereby equation 2 refers to dissociation of gas hydrates, creating an endothermic reaction. All the methane hydrates come with interconnected cages. There are three structures in methane hydrates, namely type 1, type 2, and type H. The hydrated tend to trap different kinds of molecules due to difference between the cage. In nature, the type molecule for methane hydrates is type 1 and type 2. This is a world map that shows location of known and infrared hydrates deposit in ocean and in permafrost in the year 2009. The occurrence of methane hydrate is commonly situated around equator in the ocean.
So there are two types of methane hydrate formation, which is from biogenic and methanogenic. First, biogenic methane is formed in the seafloor by the microbial breakdown of biomass. The biomass that had been broken down by the bacteria is planktonic and microalgae. So this process is known as methanogenesis. These bacteria are found at depth of around 10 meters to 3 kilometers in the sediment. Secondly, thermogenic methane is generated chemically in the deeper layer of the Earth's crust without the activity of microbial. It is similar to oil and natural gas.
The figure shows hydrate stability zone in the marine and permafrost environment. Both of the diagram illustrate the stable gas hydrate in the ocean and sediment, which does not occur in nature. By looking at deep water marine setting, which is section A, the gas hydrate is stable in the lower part of the ocean with a water depth of 1,200 meter. An estimated 99% of world gas hydrate occurs in the ocean floor with suitable pressure and temperature, whereby at the coastal, the presence of methane hydrates are most likely to be in the area of thick with permafrost. The primary production method in natural methane extraction process are thermal stimulation, vaporization, and chemical inhibitor. Chemical Thermal stimulation is a process that involves the formation of heating either through the injection or heating fluid or direct heat. An energy intensive created through thermal stimulation will cause limited conduction of gas hydrates dissociation. One of the challenges faced in the thermal stimulation process is the endothermic nature of gas hydrate. More heat need to be introduced to continuous dissociation as well as to prevent new gas hydrate formation. Depressurization. This method is more economically friendly and likely to be preferred. This is because the process relies mostly on well's life. High energy is not required, moreover the method favors rapid dissociation in a significant volume of gas hydrates. Last but not least, inhibitor injection. Certain organics such as glycol or ionic compounds such as seawater is used as a chemical inhibitor. Chemical inhibition enhances gas hydrate stability. It is not primarily used for gas dissociating. Next is the gas hydrate resources. The top of the pyramid indicates the high permeability sediment in the permafrost area. The small amount of methane hydrate is one of the earliest permafrost associating gas hydrates to be commercialized. The primary target for long-term development of methane hydrates as a source is the permeable marine sediment. The best methane hydrate target for wild-scale resource development is when the gas hydrate saturation is at moderate with high permeable marine sands. Located just below the marine sand is the gas hydrate resource pyramid is the non-sand marine sediment category. This category is best to explain less permeable sediment that might host gas hydrate in fracture-related permeability. Last but not least, low permeability marine sediment lies at the bottom of the gas hydrates pyramid. These gas hydrates category are unlikely to become the target of commercial production. This is due to its high amount of global GIP in methane hydrates.
Next, these are the novel technique in extraction of methane hydrate. So there are three techniques that have been novel. First is carbon dioxide sequestration. Second is microwave technology, and lastly is fluoride gas and microwave technology. Carbon dioxide sequestration, as been shown in the left figure, which is carbon dioxide is injected and methane gases as a product, which is at the outlet. So the heat of carbon dioxide hydrate formation is negative. Negative indicate that the heat is released, and the heat of the dissociation for methane is 54.5 kilojoule. This is favoring for the natural exchange of carbon dioxide with methane hydrate because the above changes process is exothermic. Easy to understand, gas hydrate formation is an exothermic process, while gas hydrate dissociation is endothermic process. However, CO2 sequestration have a lower limit rate of CH4 recovery compared to binary sequestration of nitrogen and carbon dioxide, which are 64 and 85% recovery respectively. It is because carbon dioxide molecules only preferably replace CH4 in large cages, whereas CH4 molecules in small cages remain almost intact. Because of such a preferential cage occupation of gas molecule, the recovery rate of CH4 was limited to the maximum value of 64%. So the second novel for the technology that has been used for methane hydrate extraction is microwave. Microwave heating is the conversion of electromagnetic energy to thermal energy. Energy transferred directly to materials by their molecular interaction with the electromagnetic field. The heat can be created throughout the volume of the material. Therefore, it can decrease processing time and prove to be energy efficient. Lastly, fluorine gas and microwave. So it can be shown at the right side of the presented slide. So this method uses a microstrip antenna with a huge power gain and a low-cost wire antenna. The tool is placed in well and a frequency of 2450 MHz is generated, which melts the gas hydrate into water and methyl radical, which destabilizes the thermodynamic condition. And after this, fluorine is injected, which results in highly exothermic halogenation and release negative 431 kJ per mole. So the tubing from production well can be used to obtain this pressurized gas. After the extraction process of methane hydride, there are three possible transportation routes. First, conventional pipeline. Second, converting the gas hydrates to liquid middle distillate via the newly improved Fischer-Tropsch process and loading it onto a conventional tanker or baggage. This secondly is like gas to liquid transformation. And thirdly is reconverting the gas into solid hydrate and shipping it ashore in a close to conventional ship or barge.
Next, I will explain on the natural methane hydrates extraction advantages, disadvantages, and the challenges of it. There are 5 advantages that can be obtained from the methane hydrates. The first one is the new possible energy source. Second, sequestration of carbon dioxide. Third, desalination for the separation processes. Fourth, capture of natural gas via methane hydrates for storage and transportation. And last but not least is the cold storage application. As I mentioned before, there are 5 advantages of methane hydrates. The first one is the possible new energy resources. Methane has a very high relative magnitude among the organic carbon on Earth. Methane hydrates, which form a gas hydrate structure able to store enormous amounts of methane. At normal conditions, a unit volume of methane hydrates may contain more than 160 volume of gas and less than 1 unit of water. Based on this, it can be said that methane hydrants have a huge amount of quantities of natural gas resource that can last for another few of decades. Hence, the utilization of this possible energy source will help to decrease the dependency on fossil fuel if it can be utilized. Next is the sequestration of carbon dioxide. Emission of carbon dioxide has promoted the increases of 67% on the greenhouse gas impact. The greenhouse effect leads to the global warming. Hence, the taking up of carbon dioxide can be done in various methods, such as through chemical absorption by amines or the sequestration through geological media and oceans, which is the methane hydrates just now. Third is desalination for separation process. This cycle is based on the formation of gas hydrate by injection of refrigerant into seawater. Desalination is also known as a gas-liquid fractionation. After the hydrate crystal have been removed from the concentrated residual brine solution, pure water can be extracted by heating the hydrates. Even though it is a great method for desalination, there is a claim that it may be difficult to implement the method due to the slurry nature of the hydrates. The fourth advantage of methane hydrates is capture of natural gas via methane hydrates for storage and transportation. The implementation of natural gas captured through methane hydrates has been conducted for a long time already. This is due to the methane hydrates that have a properties to provide a very high gas concentration. Even though the applications of methane hydrates required a very high temperature and a lower pressure compared to liquefaction and compression process, it is still a viable method to be used. Lastly is the cold storage application. The secondary refrigeration have been considered a promising alternative to overcome the impact on the environment as it helps to reduce lots of HFC in an engine room, which is due to the primary refrigeration. There are two phases that can be developed by using secondary refrigerants, which are ice slurry and hydrate slurry, whereby the carrying fluid is in an aqueous solution and in PCM ice or hydrate crystal. Next, I will explain on the disadvantages of methane hydrates. The first one is pipeline plugging. Second, environmental dilemma on usage of methane hydrates. And lastly is the climate change. The first disadvantages of methane hydrates is pipeline plugging. It is said that methane hydrates is the one responsible for blocking pipelines to form the gas hydrates. Hence, there are four methods that can be used to overcome this problem, which are through chemical method, hydraulic removal method, thermal method, and mechanical method. Even though there are all of these approaches, gas hydrate pipeline blockage remains a big problem in the oil and gas industry. In particular, deep water pipelines are gradually installed on transmission lines. Selecting an appropriate form of good and type of pipeline is needed to avoid any pipeline plugging. The next disadvantage is the environmental dilemma on usage of methane hydrate. While methane hydrates can be regarded as the main source of hydrocarbon for the future, despite that, it is still pose a real threat to the climate. It is claimed that methane hydrates can change the marine environment dramatically and subsequent gas blowouts could even be generated. In fact, it was stated that the destabilization of hydrate sediments play an obvious part in climate change. The third disadvantage is on the climate change. Methane and water are immobilized within the spaces of the sediment pores during the formation of gas hydrates. Hence, the soil cannot become dissolved because of the presence of these solids. Since the water cannot be removed, hence sedimentation appears. This scenario could lead to major undersea landslides. Next, I will explain on the challenges of methane hydrates. The first one is the escape of methane. Second, production of natural gas. And lastly is the threat to ships and airplanes. There are three challenges of methane hydrates that have been mentioned before. The first one is the escape of methane. Methane possesses a very big potential hazard. Extracting the gas from a small region of hydrates does not pose too many difficulties, but the problem is it is to avoid the breakdown of hydrates and eventual release of methane into the surrounding structures. Methane also have a significant consequence for the global warming. There is a recent findings that show that the gas is 30 times harmer than carbon dioxide. Such technological challenges are why there is no development of methane hydrates on a commercial scale anywhere in the world so far. Next is the production of natural gas. The biggest challenge with productions of natural gas is the transport of it. Natural gas is normally transported as a liquid through pipeline or tanker truck. Liquefied natural gas, LNG, is in danger of bursting due to the cause of ignition or simply a rupture of the surface. The added downside of liquefied natural gas was that it must be liquefied in order to transport amounts of it commercially, and that this process takes a very long time and required high costs. Lastly, the challenges of methane hydrates is threat to ships and airplanes. Large releases of methane from marine sediments occur on smaller scales, can even pose a danger to ships and aircraft in high methane concentration areas. It has been shown that aircraft engines unexpectedly stopped and fell in ambient methane concentration even as low as 1%. Hence, it can be said that methane hydrates have very hard challenges and in order to overcome it, a lot of research needs to be conducted. In conclusion, all of the objectives that have been stated before are achieved. Okay. For conclusions, methane hydrates could be formed into two processes, which are known as biogenic and thermogenic process. Biogenic methane is formed in the sea floor by microbial. However, thermogenic process is generated chemically in the much deeper layers of the earth crust without the activity of the microorganisms. Other than that, there are three possible routes to transfer the methane hydrate gas, which through conventional pipeline, converting the gas hydrates to liquid, and lastly converting the gas hydrate to solid. Thank you.